It is the art of determining the relative positions of different objects on the surface of the Earth by measuring the horizontal distance between them and by preparing a map to any suitable scale. The object of surveying is to prepare a map or plan to show the relative positions of the objects on the surface of the Earth. The map or plan is drawn to some suitable scale. It also shows boundaries of districts, states, and countries too. It also includes details of different engineering features such as buildings, roads, railways, dams, canals, etc. The surveying may be used for following purposes: 1. To prepare a topographical map which shows hills, valleys, rivers, forests, villages, towns, etc. of country. 2. To prepare a cadastral map showing the boundaries of fields, plots, houses, and other properties. 3. To prepare an engineering map which shows the position of engineering works such as buildings, roads, railways, dams, canals, etc. 4. To prepare military map showing roads and railways, communication with different parts of country. 5. To prepare a contour map to know the topography of the area to find out the best possible site for roads, railways, bridges, reservoirs, canals, etc. 6. To prepare archaeological map including places where ancient relics exist. 7. To prepare a geological map showing areas including underground resources. 8. For setting out work and transferring details from the map on the ground. Classification of surveying: A. Primary classification, plane surveying, geodetic surveying. B. Secondary classification. 1. Based on instruments. 2. Based on methods. 3. Based on object. 4. Based on nature of field. We know that the shape of the Earth is spheroidal. Thus the surface is obviously curved. Surveying is primarily divided into two types considering the curvature of the Earth's surface. 1. Plane surveying. 2. Geodetic surveying. 1. Plane surveying. The plane surveying is that type of surveying in which Earth's surface is considered as a plane and the curvature of the Earth is ignored. In such surveying, a line joining any two stations is considered to be straight. The triangle formed by any 3 points is considered as a plane triangle, and the angles of the triangle are considered as plane angles. Surveying is carried out for a small area of less than 250 square kilometers. It is carried out by local or state agencies like R&B Department, Irrigation Department, Railway Department. 2. Geodetic surveying. The geodetic surveying is that type of surveying in which the curvature of the Earth is taken into account. It is generally extended over larger areas. The line joining any two stations is considered as curved line. The triangle formed by any 3 points is considered to be spherical and the angles of the triangle are considered to be spherical angles. Geodetic surveying is conducted by the Survey of India Department and is carried out for a larger area exceeding 250 square kilometers. Plane surveying vs geodetic surveying. No. Plane surveying. Geodetic surveying. 1. The Earth surface is considered as the Earth surface is considered plane surface. As curved surface. 2. The curvature of the Earth is ignored. The curvature of Earth is taken into account. 3. Line joining any two stations is the line joining any two stations is considered to be straight, considered as spherical/curved line. 4. The triangle formed by any 3. The triangle formed by any 3 points is considered as plane. Points is considered as spherical. 5. The angles of triangle are considered as plane angles. The angles of the triangle are considered as spherical angles. 6. Carried out for a small area 250 square kilometers. Carried out for a small area 250 square kilometers. Survey can be classified on different bases: 1. Based on instrument, 2. Based on methods, 3. Based on objects, 4. Based on the nature of field. Survey can be classified into various categories depending on methods used and nature of the field. 1. Based on instrument, I-chain survey. This is the simplest type of surveying in which only linear measurements are made with a chain or a tape. Angular measurements are not taken. 2. Compass survey. In compass survey, the angles are measured with the help of a magnetic compass. 3. Plane table survey. It is a graphical method of surveying in which field works and plotting both are done simultaneously. 4. Theodolite survey. In theodolite survey the horizontal angles are measured with the theodolite more precisely than compass, and the linear measurements are made with a chain or tape. V. Tachyometric survey, a special type of theodolite known as tachometer, is used to determine horizontal and vertical distances indirectly. 6. Photographic survey. Photogrammetry is the science of taking measurements with the help of photographs taken by aerial camera from the aircraft. 7. Electronic distance measurement, EDM, survey. In this type of survey all measurements, length, angles, coordinates, are made with the help of EDM instrument, i.e. total station. 2. Based on methods, I. Triangulation survey. Triangulation is basic method of surveying. When the area to be surveyed is large, triangulation is adopted. The entire area is divided into network of triangles. 2. Traverse survey. A traversing is circuit of survey lines. It may be open or closed. When the linear measurements are done with a chain and a tape and the directions or horizontal angles are measured with a compass or a theodolite respectively, the survey is called traversing. 3. Based on objects, I. Geological survey. In this both surface and subsurface surveying are conducted to locate different minerals and rocks. In addition, geological features of the terrain such as folds and faults are located. 2. Mine survey. Mine survey include both surface and underground surveys. It is conducted for the exploration of mineral deposits and to guide tunneling and other operations associated with mining. 3. Archaeological survey. It is conducted to locate relics of antiquity, civilization, kingdoms, forts, temples, etc. 4. Military survey. It has a very important and critical applications in the military. Aerial surveys are conducted for this purpose. It is conducted to locate strategic positions for the purpose of army operations. 4. Based on nature of field, I. Land survey. Land survey is done on land to prepare plan and maps of a given area. Topographical, city and cadastral surveys are some of the examples of land surveying. 2. Marine survey. This survey is conducted on or near the body of water such as lake, river, coastal area. This survey consists of locating shore lines of water bodies. 3. Astronomical survey. This survey is conducted for the determining of latitudes, longitudes, azimuths, local time, etc. for various places on Earth by observing heavenly bodies, sun or the stars. 1. Always work from whole to the part. According to the first principle, the whole survey area is first enclosed by main stations, i.e. control stations, and main survey lines. The area is then divided into a number of divisions by forming well-conditioned triangles. 1. Always work from whole to the part. The main survey lines are measured very accurately with precise survey instruments. The remaining sides of the triangle are measured. The purpose of this method of working is to control accumulation of errors. During measurement, if there is any error, then it will not affect the whole work, but if the reverse process is followed then the minor error in measurement will be magnified. 2. To locate a new station by at least 2 measurements, linear or angular, from fixed reference points. According to the second principle, the points are located by linear or angular measurement or by both in surveying. If 2 control points are established first, then a new station can be located by linear measurement. Let A and B are control points, a new point C can be established. Following are the methods of locating point C from such reference points A and B. The distance of can be measured accurately and the relative positions of the point can be then plotted on the sheet to some scale. A. Taking linear measurement from A and B for C. B. Taking linear measurement of perpendicular from D to C. C. Taking one linear measurement from B and one angular measurement as _ABC. D. Taking 2 angular measurement at A and B as angle/_cab and /ABC. E. Taking 1 angle at B as /_ABC and 1 linear measurement from A as AC1. Linear 2. Angular units: 1 foot equals 12 inch, 1 yard equals 3 feet, 1 chain equals 66 feet, 1 furlong equals 10 chain, 1 mile equals 5,280 feet and 1.6 kilometers. A direct methods. B optical methods. CE.D.M methods. A direct method of measuring distance. 1 pacing, where approximate result is required, distance may be determined by pacing. This method is used for reconnaissance survey, for preparation of military plans. Also used for approximate checking distance. The method consists of walking over a line and counting the number of paces, 80 centimeters. The required distance may be obtained by multiplying the number of paces by the average length of pace. The length of pace varies with the individual, age, height and physical condition, the nature of the ground, uphill and downhill, the slope of the country and the speed of pacing. A direct method of measuring distance. 2 passometer. It is a pocket instrument. It automatically records the number of paces. It should be carried vertically, in waistcoat pocket or suspended from a button. The mechanism being operated by motion and strain of the body. A direct method of measuring distance. 3 pedometer. It is similar to passometer, but it registers the distance walked by the persons carrying it. The distance is read by means of an indicator. It is fitted with a stud or knob, which when pressed release indicator to 0, it may be carried in the same way as the passometer. A direct method of measuring distance. 4 odometer. It measures the distance approximately. It can be attached to the wheel of any vehicle, such as carriage, cart, bicycle, etc. It registers the number of revolution of the wheel. Knowing the circumference of the wheel, the distance traversed may be obtained by multiplying the number of revolutions by the circumference of the wheel. A direct method of measuring distance. 5 speedometer. The speedometer of an automobile may be used to measure distances approximately. It gives better results than pacing, provided the route is smooth. A direct method of measuring distance. 6 perambulator. It can measure distance rapidly. It consists a single wheel provided with forks and a handle. It is wheeled along the line, the length of which is desired. The distance traversed is automatically registered on the dial. The reading approximates on rough ground. A direct method of measuring distance. 7 judging distance. This is very rough method of determining distance. It is used reconnaissance survey. 8 time measurement. This distance is roughly determined by time intervals of travel. Knowing the average time per km for a person at walk or a horse, the distance traversed may be easily obtained. A direct method of measuring distance. 9 chaining. Measuring the distance with chain or rope or tape is the most accurate and common method, called as chaining. For work of ordinary precision a chain is used. Where great accuracy is required, a steel tape is used. B optical method of measuring distance. In the optical methods, principles of optics are used. The distance is not actually measured in field but it is computed indirectly. The instrument used for making observations is called tachyometer. B optical method of measuring distance. CEDM method of measuring distance. Electronic distance measuring. E.D.M. Instruments have been developed quite recently. These are practically replacing the measurement of distances using chains or tapes. There is a large variety of such instruments and depending upon the precision required the instruments should be used. The following instruments are required for measurements with chain and tape. 1 chains 2. Tape 3. Ranging rods 4. Offset rods 5. Arrows 6. Pegs 7. Plumb bob and 8. Line Ranger 1. Chain. Various types of chains used in surveying are: I-metric chain 2. Gunter's chain or surveyor's chain 3. Engineer's chain 4. Revenue chain V. Steel band or band chain. I-metric chain. Normally, a chain is prepared with 100 or 150 pieces of galvanized mild steel wire of 4 mm diameter known as link. The ends of the links are bent into loop and connected together by means of 3 oval rings which provide the flexibility to the chain and make it less liable to kinking. Both ends of the chain have brass handle with swivel joint so that the chain can be turned round without twisting. Imetric chain. In a metric chain at every 1 meter interval of chain, a small brass ring is provided. Brass tallies are also provided at every 5.0 m length of chain. Each tally has different shape which indicates 5, 10, 15 m from any one side of the chain. Metric chains are available in 20 m and 30 m length. A 20 m chain has 100 links each of 20 centimeters and 30 m chain has 150 links. Length of chain is embossed on the brass handles of the chain. Imetric chain. 2. Gunter's chain or surveyor's chain. A 66 feet long chain consists of 100 links each of 0.66 feet. It is known as Gunter's chain here. 10 SQ chain are equal to 1 acre, 10 chains equals 1 furlong and 8 furlongs equals 1 mile. This chain is suitable for taking length in miles and areas in acres. 2 Gunter's chain or surveyor's chain. 3. Engineer's chain. A 100 feet chain of 100 links each of 1 foot is known as engineer's chain. Brass tags are fastened at every 10 links. This chain is used to measure length in feet and area in square yards. 3 Engineer's chain. 4. Revenue chain. Revenue chain is 33 feet long chain consisting of 16 links. This chain is used for distance measurements in feet and inches for small areas. V steel band or band chain. Steel bands are preferred than chains because they are more accurate, but the disadvantages is that they get broken easily and are difficult to repair in the field. They are 20 and 30 m long, 12 to 16 mm wide and 0.3 to 0.6 mm thick. They are numbered at every meter and divided by brass studs at every 20 cm. V steel band or band chain. 2 tapes. Tapes are used for more accurate measurement. The tapes are classified based on the materials of which they are made of, such as I-cloth or linen tape. 2. Fiber tape. 3. Metallic tape. 4. Steel tape. V-invar tape. 2. Tapes. I-cloth or linen tape. Linen tapes are closely woven linen and varnished to resist moisture. They are generally 10 m, 20 m, 25 m, and 30 m long in length and 12 to 15 mm wide. They are generally used for offset measurements. These tapes are light and flexible. I-cloth or linen tape. 2. Fiberglass tape. These tapes are similar to linen and plastic coated tapes, but these are made of glass fiber. The tapes are quite flexible, strong, and non-conductive. These can be used in the vicinity of electrical equipment. These tapes do not stretch or shrink due to changes in temperature or moisture. These tapes are available in length of 20 m, 30 m, and 50 m length. 2 Fiberglass tape. 3. Metallic tape. A linen tape reinforced with brass or copper wires to prevent stretching or twisting of fibers is called a metallic tape. As the wires are interwoven and tape is varnished, these wires are visible to naked eyes. This is supplied in a lather case with a winding device. Each meter length is divided into 10 parts, decimeters, and each part is further subdivided into 10 parts. It is commonly used for taking offset in chain surveying. 3 Metallic tape. 4. Steel tape. The steel tape is made of steel ribbon of width varying from 6 to 16 mm. The commonly available length are 10 m, 15 m, 20 m, 30 m, and 50 m. It is graduated in meters, decimeters, and centimeters. Steel tapes are used for accurate measurement of distances. 4 Steel tape. V-invar tape. Invar tape are made of alloy of nickel 36% and steel 64%, having very low coefficient of thermal expansion. These are 6 mm wide and generally available in length of 30 m, 50 m, 100 m. It is not affected by change of temperature, therefore, it is used when high degree of precision is required. V-invar tape. 3. Ranging rods. Ranging rods are used for ranging some intermediate points on the survey line. Ranging rods are generally 2 to 3 m in length and are painted with alternate bands of black or white or red and white color with length of each equalizing 20 centimeters. The location of any survey station can be known from long distances only by means of ranging rods. If the distance is too long, a rod of length 4.0 to 6.0 m is used and is called ranging pole. 3 Ranging rods. 4 Offset rods. The offset rod is similar to ranging rod with the exception that instead of the flag, a hook is provided at the top for pushing and pulling the chain or the tape. It is also used for measuring small offsets. Ranging rods and offset rods, 5 arrows. Arrows are made of tempered steel wire of diameter 4 mm. One end of the arrow is bent into ring of diameter 50 mm and the other end is pointed. Its overall length is 400 mm. Arrows are used for counting the number of chains while measuring a chain line. An arrow is inserted into the ground after every chain length measured on the ground. 6 pegs. Pegs are made of timber or steel and they are used to mark the position of the station or terminal points of a survey line. Generally, pegs are 15 cm long and are driven into the ground with the help of a hammer. 7 plumb bob. Plumb bob is used to transfer points on the ground. It is also used for fixing the instruments exactly over the station point marked on the ground by checking the center of the instrument whether coincides with the center of the peg or station knot, by suspending the plumb bob exactly at the center of the instrument under it. Plumb bob is thus used as centering aid in theodolites and plane table. 8 line ranger. It is an optical instrument used for locating a point on a line and hence useful for ranging. It consists of 2 isosceles prisms placed one over the other and fixed in an instrument with handle. The diagonals of the prisms are silvered so as to reflect the rays. Its advantage is it needs only one person to range. The instrument should be occasionally tested by marking 3 points in a line and standing on middle point observing the coincidence of the ranging rods. 8 line ranger. If the images of the 2 ranging rods do not appear in the same line, one of the prism is adjusted by operating the screw provided for it. 8 line ranger. To locate point C on line of Ref. Fig. The surveyor holds the instrument in hand and stands near the approximate position of C. If he is not exactly on line of, the ranging rods at A and B appear separated as shown in Fig. B. The surveyor moves to and from at right angles to the line of till the images of ranging rods at A and B appear in a single line as shown in Fig. C. It happens only when the optical square is exactly on line of B. Thus the desired point C is located on the line of B. 9 cross staff. 3 different types of cross staffs used for setting perpendicular offsets. All cross staffs are having 2 perpendicular lines of sights. The cross staffs are mounted on stand. First line of sight is set along the chain line and without disturbing setting. Right angle line of sight is checked to locate the object. 9 cross staff. With open cross staff, Fig. A, it is possible to set perpendicular only, while with French cross staff, Fig. B, even 45-degree angle can be set. Adjustable cross staff can be used to set any angle also, since there are graduations and upper drum can be rotated over lower drum. 10 cross staff. With open cross staff, Fig. A, it is possible to set perpendicular only, while with French cross staff, Fig. B, even 45-degree angle can be set. Adjustable cross staff can be used to set any angle also, since there are graduations and upper drum can be rotated over lower drum. Chain surveying is the type of surveying in which only linear measurements are taken in the field. This type of surveying is done for surveying of small extent to describe the boundaries of plots of land and to locate the existing feature on them. It is the method of surveying in which the area is divided into network of triangles and the sides of the various triangles are measured directly in the field with a chain or a tape and no angular measurements are taken. Triangulation is the principle of chain surveying. The principle of chain surveying is to divide the area into a number of triangles of suitable sides. As a triangle is the only simple plane geometrical figure which can be plotted from the length of the 3 sides even if the angles are not known. A network of triangles is preferred to chain surveying. If the area to be surveyed is triangle in shape and if the lengths and sequence of its 3 sides are recorded, the plan of the area can be easily drawn. Survey stations. Survey stations are the points at the beginning and at the end of a chain line. They may also occur at any convenient position on the chain line. Such station may be main stations, subsidiary stations, tie stations, survey stations, main stations. Main stations along the boundary of an area as controlling points are known as main stations. The main stations are denoted by Subsidiary stations, stations which are on the main survey lines or any other survey lines are known as subsidiary stations. These stations are taken to run subsidiary lines for dividing the area into triangles, for checking the accuracy of triangles and for locating interior details. Tie stations, these stations are also subsidiary stations taken on the main survey lines. Lines joining the stations are known as tie lines. Tie lines are taken to locate interior details. Survey lines, main survey lines, the line joining the main stations are called main survey lines or chain lines. The main survey lines should cover the whole area to be surveyed. Base lines, the line on which the framework of the survey is built is known as baseline. It is the most important line of the survey. Generally, the longest of the main survey lines is considered as the baseline. This lines should be taken through fairly level ground, and should be measured very carefully and accurately. Survey lines, check lines, the line joining the apex point of a triangle to some fixed points on its base is known as check line. It is taken to check the accuracy of the triangle. Sometimes this line helps to locate interior details. Tie line, a line joining tie stations is termed as a tie line. It is run to take the interior details which are far away from the main lines and also to avoid long offsets. It can also serve as check line. The following points should be considered while selecting survey stations. It should be visible from at least 2 or more stations. As far as possible, main lines should run on level ground. All triangles should be well conditioned, no angle less than 30 degrees. Main network should have as few lines as possible. Each main triangle should have at least one check line. Obstacles to ranging and chaining should be avoided. Sides of the larger triangles should pass as close to boundary lines as possible. Trespassing and frequent crossing of the roads should be avoided. The following operations are involved in chain surveying. 1. Chaining. 2. Ranging. 3. Offsetting. These 3 operations are done simultaneously during chain surveying. 1. Chaining. Chaining on level ground. A method of taking measurement with the help of chain or tape is termed as chaining. Chaining involves following operations: A. Fixing the stations. B. Unfolding the chain. C. Ranging. D. Measuring the distance, survey line. E. Folding the chain. 1. Chaining. A. Fixing of stations. Stations are first of all marked with pegs and ranging rods to make them visible. B. Unfolding of a chain. To open a chain, the strap is unfastened and the 2 brass handles are held in the left hand and the bunch is thrown forward with the right hand. Then one chainman moves forward by holding the other handle until the chain is completely extended. 1. Chaining. C. Ranging. The process of establishing intermediate points on a straight line between 2 endpoints is known as ranging. Ranging must be done before a survey line is chained. 1. Chaining. C. Ranging. 1. Chaining. D. Measuring the distance, survey line. 2 persons are required in this operation, i.e. leader and follower. The chainman at the forward end of the chain who drags the chain forward, is known as the leader. The chainman at the rear end of the chain, who holds the 0 end of the chain at the station, is known as the follower. To chain the line, the leader moves forward by dragging the chain line and taking with him ranging rod and 10 arrows. The follower stands at the starting station by holding the other end of the chain. 1. Chaining. D. Measuring the distance, survey line. When the chain is fully extended, the leader holds the ranging rod vertically at arm's length. The follower directs the leader to move his rod to the left or right until the ranging rod is exactly in the line. Then the follower holds the 0 end of the chain by touching the station peg. The leader stretches the chain by moving it up and down with both hands, and finally place it on the line. He then inserts an arrow on the ground at the end of the chain and mark it with cross. Again the leader moves forward by dragging the chain with 9 arrows and the ranging rod. 1. Chaining. D. Measuring the distance, survey line. At the end of the chain, he fixes another arrow as before. As the leader moves further, the follower picks the arrow which were inserted by the leader. During chaining, the surveyor or an assistant should conduct the ranging operation. In this way, chaining is continued. When all the arrows are inserted, the leader has none left with him. the follower hands over to the leader. To measure the fractional length, the leader should drag the chain beyond the station and the follower should hold the zero end of the chain at last arrow, then odd links should be counted. 1 Chaining, D, measuring the distance, survey line 1. Chaining, D, measuring the distance, survey line 1. Chaining, E, folding of chain, to fold the chain, a chainman should move forward by pulling the chain at the middle. Then the two halves of the chain will come side by side. After this, commencing from the central position of the chain, 2 pairs of links are taken at a time with the right hand and placed on the left hand alternately in both directions. Finally the 2 brass handles will appear at top. The bunch should be then fastened by the strap. 2 Ranging, when a survey line is longer than a chain length, it is necessary to align intermediate points on chain line so that the measurements are along the line. The process of locating intermediate points on survey line is known as ranging. There are 2 methods of ranging, viz., I-direct ranging and 2. Indirect/reciprocal ranging. 2 Ranging, I-direct ranging. If the first and last points are intervisible, this method is possible. Stations A and B in which an intermediate point C is to be located. Point C is selected at a distance slightly less than a chain length. 2 Ranging, I-direct ranging. At points A and B ranging rods are fixed. 2 Ranging, I-direct ranging. The assistant holds another ranging rod near C. Surveyor positions himself approximately 1 m behind station A and looking along line of directs the assistant to move at right angles to the line of till he aligns the ranging rod along a 2 Ranging, I-direct ranging. Then surveyor instructs the assistant to mark that point and stretch the chain along AC2. Ranging, I-indirect/reciprocal ranging. Due to intervening ground, if the ranging rod at B is not visible from station A, reciprocal ranging may be resorted. Figure shows the scheme of ranging. 2 Ranging, I-indirect/reciprocal ranging. It needs 2 assistants, one at point M and another at point N, where from those points both station A and station B are visible. It needs 1 surveyor at A and another at B to start with M and N are approximately selected, say M1 and N1. Then surveyor near end A ranges person near M to position M2 such that A, M2, N1 are in a line. Then surveyor at B directs person at N, to move to N2 such that B, N2, M2 are in a line. The process is repeated till A, M and B are in a line. 2 Ranging, I-indirect/reciprocal ranging. It needs 2 assistants, one at point M and another at point N, where from those points both station A and station B are visible. It needs 1 surveyor at A and another at B to start with M and N are approximately selected, say M1 and N1. Then surveyor near end A ranges person near M to position M2 such that A, M2, N1 are in a line. Then surveyor at B directs person at N, to move to N2 such that B, N2, M2 are in a line. The process is repeated till A, M and B are in a line. During continuous use, the length of a chain gets altered. Its length is shortened chiefly due to the bending of links. Its length is elongated either due to stretching of the links and joints and opening out of the small rings. For accurate work it is necessary to test the chain time to time. The chain can be thus tested by a steel tape or by a standard chain. Sometimes, it is convenient to have a permanent test gauge established where the chain is tested. When the length of a chain is measured at a pull of 8 kg at 20 degrees C, the length of the chain should measure 20 m plus or minus 5 mm and 30 m plus or minus 8 mm. For 20 m and 30 m long chain shall be accurate to within 2 mm. Following measures are taken to adjust the length of a chain. 1. If chain is found to be too long, it can be adjusted by closing up the joints of the rings. If found to be opened out, reshaping damaged rings, removing one or more small rings, adjusting the links at the end. 2. If the chain is found to be too short, straightening the bent links, opening the joints of the rings, replacing one or more small circular rings by bigger ones. Inserting new rings where necessary. Adjusting the links at the end. 3. Offsetting, lateral measurements to chain lines for locating ground features are known as offsets. For this purpose, perpendicular or oblique offsets may be taken. If the object to be located, say road, is curved, more number of offsets should be taken. For measuring offsets, tapes are commonly used. 3. Offsetting. I. Perpendicular offsets. The offsets which are taken perpendicular to the chain line are termed as perpendicular offsets. These offsets are taken by holding zero end of the tape at the object and swinging the tape on the chain line. The shortest distance measured from object to the chain line is usually the perpendicular offset. 3. Offsetting. 2. Oblique offsets. Oblique distance is always greater than perpendicular distance. All the offsets which are not taken at the right angle to chain line are known as oblique offsets. 3. Offsetting. For setting perpendicular offsets, any one of the following methods are used: I. Swinging. 2. Using cross staffs. 3. Using optical or prism square. 3. Offsetting. I. Swinging. Chain is stretched along the survey line. An assistant holds the end of tape on the object. 3. Offsetting. I. Swinging. Surveyor swings the tape on chain line and selects the point on chain where offset distance is the least and notes chain reading as well as offset reading in a field book on a neat sketch of the object. 3. Offsetting. I. Swinging. Surveyor swings the tape on chain line and selects the point on chain where offset distance is the least and notes chain reading as well as offset reading in a field book on a neat sketch of the object. 3. Offsetting. 2. Using cross staff. 3 different types of cross staffs used for setting perpendicular offsets. All cross staffs are having 2 perpendicular lines of sights. The cross staffs are mounted on stand. First line of sight is set along the chain line and without disturbing setting. Right angle line of sight is checked to locate the object. 3. Offsetting. 2. Using cross staff. With open cross staff, Fig. A, it is possible to set perpendicular only, while with French cross staff, Fig. B, even 4-5-degree angle can be set. Adjustable cross staff can be used to set any angle also, since there are graduations and upper drum can be rotated over lower drum. 3. Offsetting. 2. Using optical square and prism square. An optical square is also used for setting out right angles. It consists of a small circular metal box of diameter 5 cm and depth 1.25 cm. It has a metal cover which slides round the box to cover the slits. The following are the internal arrangements of the optical square. 1. A horizon glass H is fixed at the bottom of the metal box. The lower half of the glass is unsilvered and the upper half is silvered. 2. A index glass I is also fixed at the bottom of the box which is completely silvered. 3. The angle between the index glass and horizon glass is maintained at 450. 3. Offsetting. 2. Using optical square and prism square. 4. The opening E is a pinhole for IE, B is a small rectangular hole for ranging rod B, P is a large rectangular hole for object P5. The line EB is known as horizon sight and IP as index sight. 6. The horizon glass is placed at an angle of 1200 with the horizon sight. The index glass is placed at an angle of 1050 with the index sight. 7. The ray of light from P is first reflected from I, then it is further reflected from H, after which it ultimately reaches the IE3. Offsetting. 2. Using optical square and prism square. 3. Offsetting. 2. Using optical square and prism square. Principle. According to the principle of reflecting surfaces, the angle between the first incident ray and the last reflected ray is twice the angle between the mirrors. In this case, the angle between the mirrors is fixed at 450. So, the angle between the horizon sight and index sight will be 900. Setting up the perpendicular by optical square A. The observer should stand on the chain line and approximately at the position where the perpendicular is to be set up. 3. Offsetting. 2. Using optical square and prism square. B. The optical square is held by the arm at the eye level. The ranging rod at the forward station B is observed through the unsilvered portion on the lower part of the horizon glass. C. Then the observer looks through the upper silvered portion of the horizon glass to see the image of the object PD. Suppose the observer finds that the ranging rod B and the image of object P do not coincide. He should move forward or backward along the chain line until the ranging rod B and the image of P exactly coincide. At this position the observer marks a point on the ground to locate the foot of the perpendicular. Field Book 1. Correction for temperature 2. Correction for sag 3. Correction for tension 4. Correction for altitude 5. Correction for slope 6. Correction for alignment 7. Correction for standard length 1. Correction for temperature, the length of the tape increases while the temperature is increased and decreases if the temperature is lowered. Where L equals measured length of a line, T equals mean temperature during measurement in Ts equals nominal temperature of standardization. Ct equals correction due to temperature equals coefficient of linear expansion, 6.510-60 F, or 11.210-60 C2. Correction for sag, when the tape is suspended from two support in air, assumes the shape of centenary. Where Cs equals correction for sag, W equals weight per unit length, L equals measured length of open, P equals pull applied during measurement 3. Correction for tension, if the pull applied to the tape during measurements is more than it is standardized, its length increase and the measured distance become less than the actual. Correction for tensions is therefore positive. Let P equals the tension of pull at field, N. PS equals standardized tension. N. L equals length measured. A equals cross-sectional of steel band. E equals Young's modulus of elasticity of the steel bond. Tan equals correction for tension 3. Correction for altitude, if the surveying is connected to the functional mapping of the country, the distance will need to be reduced to the common datum at that system normally. The correction for altitude for surface work is negative and positive for tunneling work or mining work below MSL. A chain line may be interrupted in the following situations: 1. When chaining is free, but vision is obstructed. 2. When chaining is obstructed, but vision is free. 3. When chaining and vision both are obstructed. 1. When chaining is free, but vision is obstructed. Such problems arises when a rising ground or a jungle area interrupts the chain line. Here the end stations are not intervisible. There may be two cases. Case I, both ends may be visible from intermediate points on the line. Case 2, both ends may not be visible from any intermediate point. 1. When chaining is free, but vision is obstructed. Case I, the end stations may be visible from some intermediate points on the rising ground. In this case, reciprocal ranging is resorted to, and the chaining is done by the stepping method. 1. When chaining is free, but vision is obstructed. Case 2, the end stations are not visible from intermediate points when a forest area comes across the chain line. In this case, the obstacle may be crossed over using a random line as explained below. 1. When chaining is free, but vision is obstructed. Case 2, let A be the line whose length is required. From A run a line, AB1, called a random line, in any convenient direction, but as nearly towards B as can be judged, and continue it until the point B is visible from B1. Chain the line to B1 where BB1 is perpendicular to AB1 and measure BB1. Then, 1. When chaining is free, but vision is obstructed. Case 2, if any other length AC1 is measured along AB1, a point C is located on the line of by measuring the perpendicular distance C1. C equals AC1/1 times B1B. In this manner a sufficient number of points can be located. The line is then cleared and the distance measured. 2. When chaining is obstructed, but vision is free, when a pond, plantation, tank, river, etc. The problem is to find the distance between two convenient points on the chain line on either side of the obstacle. There are two cases: Case I, in which it is possible to chain round obstacle, e.g. a pond, a bend in the river, etc. Case 2, in which it is not possible to chain round the obstacle, e.g. a river. 2. When chaining is obstructed, but vision is free. Case I, in which it is possible to chain round obstacle, e.g. a pond, a bend in the river, etc. A. Select two convenient points A and B on the chain line PR and on either side of the obstacle, figure 3.38. Erect equal perpendicular AC and BD by the 3, 4, 5 method or the optical square and measure the length CD. Then AB equals CD2. When chaining is obstructed, but vision is free. Case I, in which it is possible to chain round obstacle, e.g. a pond, a bend in the river, etc. B. As before, select A and B, set out a perpendicular above such a length that CB clears the obstacle, and measure AB and CB. Then AC equals BC superscript 2 AB superscript 2. 2. When chaining is obstructed, but vision is free, case I, in which it is possible to chain round obstacle, e.g. a pond, a bend in the river, etc. C. The measurement may be effected by constructing a right-angled triangle. Select a point A, figure 3.40, on the chain line on one side of the obstacle and set out AC to clear the obstacle. At C, erect a perpendicular CB with the optical square to clear the obstacle, and determine the point B on the chain line on the other side. Measure AC and CB. Then, AB equals AC superscript 2 plus CB superscript 2 2. When chaining is obstructed, but vision is free, case I, in which it is possible to chain round obstacle, e.g. a pond, a bend in the river, etc. D. Select two convenient points A and B on the chain line PR on opposite sides of the obstacle, figure 3.41. Select a point C so that AC and BC clear the obstacle. Produce the line AC to E so that CE equals AC. Similarly, continue BC to D so that CD equals to BC. Measure D. The triangle CDE and CBA being equal in all respects, AB equals D. 2. When chaining is obstructed, but vision is free, case 2, in which it is not possible to chain round the obstacle, e.g. a river. A. Select 2 points A and B on the chain line PR on opposite banks of the river. Set out a perpendicular AD and bisect it at C, midpoint of AD. At D, erect a perpendicular D and mark the point E in line with C and B. Measure D. Since the triangles ABC, said are similar, hence AB equals D2. When chaining is obstructed, but vision is free, case 2, in which it is not possible to chain round the obstacle, e.g. a river. B. For large river, select 2 points A and B on the chain line PR on either side of the river. Mark another point E on the chain line. At A and E, erect perpendiculars AC and AD such that D, C, and B are in the same line. Measure AC, AE, and AD. If a line CF is drawn parallel to AE, meeting AD in F, the triangles ABC and CFD are similar. 2. When chaining is obstructed, but vision is free, case 2, in which it is not possible to chain round the obstacle, e.g. a river. B. Therefore, AB/AC equals CF/FD, but CF equals AE and FD equals AD/AC, or AB/AC equals AE/AD/AC, whence BA equals AC times AE/AD/AC, 2. When chaining is obstructed, but vision is free, case 2, in which it is not possible to chain round the obstacle, e.g. a river. C. As before, select 2 points A and B, set off a perpendicular AD at A. With a cross staff or an optical square, erect a perpendicular to DB at D, cutting the chin line at C. Measure AD and AC. Since the triangles ABD and ACD are similar, AB/AD equals AD/AC. Hence, AB equals AD superscript 2/CA2. When chaining is obstructed, but vision is free, case 2, in which it is not possible to chain round the obstacle, e.g. a river. D. If a box sextant is available, the following method may be used. Fix 2 points A and B as before. At A, erect a perpendicular AC of any convenient length so that the triangle ABC is well conditioned. Measure AC, and the angle ACB with the box sextant. The distance AB may then be calculated from AB equals AC tan/_ACB equals AC tan 2. When chaining is obstructed, but vision is free, case 2, in which it is not possible to chain round the obstacle, e.g. a river. E. This method is used when a survey line crosses a river obliquely. Set out line AE at a convenient angle with the survey line PR and range point D in line with E and A, making AD equals AE. Using an optical square, set out perpendiculars DB and EC to the line at D and E, intersecting the survey line PR at B and C respectively. Measure AC. The triangles ADB and AEC being congruent, the required length of is equal to AC3. When chaining and vision both are obstructed, in this case the problem consists in prolonging the line beyond the obstacle and determining the distance across it. A building is a typical example of this class of obstacle. Choose point A and B on the chain line PR. At A and B erect perpendiculars AE and BF of equal length. Check the diagonals B and AF, which should be equal, and also F, which should be equal to AB. Prolong the line F past the obstacle and select 2 points G and H on it. At G and H set out perpendiculars GC and HD equal in length to AE. The points C and D are obviously on the chain line PR and BC equals FG. Great care must be taken in setting out the perpendiculars very accurately and to see that their lengths are exactly equal.